Hello everyone, welcome to another exciting math problem focusing on inequality, a challenging concept for beginners. Today's problem is, suppose b squared is greater than or equal to 4c. Find the minimum value of b minus 1 squared plus b minus c squared plus c minus 1 squared. Before I uncover the solution, I encourage you to hit the pause button, grab your pen and paper, and try to solving it on your own. When you are ready, feel free to post your answers in the comments below. Then we'll dive into the solution together. Let's begin. Note that if we express b minus 1 squared plus b minus c squared plus c minus 1 squared as a, it represents an ellipse. It's evident that if b equals to 1 and c equals to 1, then a equals to 0. Let's examine the graph of this ellipse using GeoGebra. Remember, there's a constraint. B squared must be greater than or equal to 4c, where b squared equals 4c form a parabola. We'll illustrate this using GeoGebra as well. What do you observe? The ellipse lies within the region where b squared is at least 4c, indicated by the blue shaded area. Interestingly, the minimum value of a occurs when b squared equals 4c. With this condition, our expression transforms into b minus 1 squared plus b minus b squared over 4 squared plus b squared over 4 minus 1 squared. Expanding this, use a 4th degree polynomial. That is 1 over 8 times b power 4 minus 4b power 3 plus 12b squared minus 16b plus 16. Take a moment to pause the video and try computing the square. Did you arrive at 1 over 8 times b squared minus 2b plus 4 squared? Computing the square again, we will get 1 over 8 times b minus 1 squared plus 3 squared. Clearly, the minimum value is 9 over 8. Always verify the equality case. Here, it holds if and only if b equals 1 and c equals 1 over 4. Now, let's discuss another approach, which we'll call method 2. Note that the constraint b squared is greater than or equal to 4c resemble as b squared is greater than or equal to 4ac with a equals 1. This relates to the discriminant of a quadratic equation where real roots exist if the discriminant is non-negative. Suppose alpha and beta are real numbers represents the roots of x squared plus bx plus c equals 0. Via Vieta formulas, the sum of the roots alpha plus beta equals negative b, and their product alpha beta equals c. Substituting b and c with negative alpha minus beta and alpha beta, we expand and rearrange the terms to derive a new expression. Pause here and try to factorize it. Did you get 2 times alpha squared plus alpha plus 1 times beta squared plus beta plus 1? Computing the square, we'll find the expression's minimum value to be 2 times 3 over 4 times 3 over 4, which equals 9 over 8. Remember to consider the equality case, which occurs when alpha equals beta equals negative half, leading to b equals 1 and c equals 1 over 4. Revisiting the graph, the intersection point is at 1, 1 over 4, corresponding to the values of b and c. And the value of a is 1.125, which equals 9 over 8. In conclusion, we explore two methods to tackle this problem, both giving the solution 9 over 8. While we have successfully solved this problem, practicing is the key to mastery. Using a similar approach, try solving the following question and share your solutions in the comment. That's all for today's lesson. I hope you found this video insightful and look forward to more math challenge ahead. Until next time, take care and bye-bye.